In this video, we'll discuss computing odds. Please use your guided notes from Blackboard to follow along. We'll begin with definitions. Let the probability of A be the probability that A occurs. Let P of not A be the probability that A does not occur. Odds in favor of event A are the probability of event A divided by the probability that event A does not occur, or the probability of A divided by 1 minus the probability of A. Remember, we learned that the probability of A plus the probability of not A is equal to 1 because they're complementary events. When we manipulate that formula, that's how we get the probability of not A is equal to 1 minus probability of A. And that's what we see in the denominator of our formula there. On the right-hand side, we see our formula for odds in favor written in words. Odds in favor is equal to the number of favorable outcomes divided by the number of unfavorable outcomes. Now, we can write odds in a fraction, but oftentimes we'll see odds written with a colon. And on the left side, we'll have the number of favorable outcomes. And on the right side, we'll have the number of unfavorable outcomes. Written in fraction form, sometimes we can confuse odds with probabilities. In odds, we have favorable outcomes to unfavorable outcomes. In probability, if we were finding the probability of event A happening, we would have the number of ways event A can happen over the total number of outcomes. Just like we can find odds in favor, we can also find the odds against your event A. It's the probability of not A divided by the probability of A, or 1 minus P of A over P of A. What happens? We switch or flip the fractions from odds in favor in order to get odds against. On the right side, we see odds against in words, the number of unfavorable outcomes to the number of favorable outcomes. Once again, you can see that we've flipped the fraction over to get odds against. Note for odds against, first we have the number of unfavorable outcomes, so the number that's associated with not A comes first. And then on the right-hand side, we'll have the number that's associated with A, event A happening. Above, for odds in favor, we'll have the number of favorable outcomes, which associates with event A, and then we'll have the number of unfavorable outcomes, which associates with not A in that case. So if for odds in favor, the A comes first. For odds against, the not A, or the event not occurring, the number associated with that will come first. Let's look at some examples. We're going to find the odds in favor of each of these events occurring. First, what are the odds in favor of rolling a number less than 5 on a die? First, our sample space, when we roll a die, we can have a 1, 2, 3, 4, 5, or a 6. The numbers associated with less than 5 would be 1 through 4. So that's our event A. The numbers associated with 5 or greater would be 5 and 6. So those are the numbers we associate with not A. So our probability is going to be, the probability of A is going to be 4 out of 6, or 2/3. The probability of the event not A is going to be 2 out of 6, or 1/3. So using our formula, we're going to have 2/3 divided by 1/3. When you divide fractions, you copy the top, put a multiplication dot, and flip the bottom, and multiply across, and simplify. So we'll get 6 over 3, or 2 to 1. For odds, we would leave this as 2 to 1, or we would write it as 2 to 1. You don't simplify it to just 2. An alternate way to do this problem is to take the number of items associated with A to the number of items associated with not A. In this problem, we had 4 items that belonged to the set of A, and then we had 2 items that belonged to the set of not A. We can reduce that by dividing both sides by 2. And we'll get 2 to 1 once again. You may use either method. Next, we'll find the odds in favor of tossing heads on a fair coin. So we can think of that as ways to get heads to the number of ways to get tails. Let's see. There's 1 way to get heads to 1 way to get tails. So the odds in favor of head is 1 to 1. Next, we have drawing an ace from an ordinary 52 card deck. Well, how many aces are there? There are 4 aces. And if there's 52 cards, we're going to have 52 minus 4, or 48 other cards. So the odds in favor of drawing an ace would be 4 to 48. We can simplify that to 1 to 12. Well, that makes sense because every suit has 13 cards total, and one of those 13 cards is an ace, and 12 of them are other cards. Lastly, we want the odds in favor of drawing a heart from an ordinary deck. So we're thinking of how many ways can we get a heart to how many ways we can have not heart. Well, we know that there are 52 cards in a deck, and 13 of them are hearts. So that means that 39 are not hearts. If we divide both sides by 13 here, we're going to get 1 to 3. And that makes sense because there's 4 suits in a deck. One of the suits is hearts, and 3 of them are not. If I know the odds in favor or odds against an event, then I can use that to find the probability of that event happening. If I know the odds in favor of event E is m to n, then I can say the probability of E is m over m plus n. When I'm seeing odds in favor of E, then when I see the odds are m to m, that m is associated with the way E happens. N is associated with the way not E happens. Whereas if I see odds against an event E, that means that the first number I see in this odds right here is associated with not E because it said against here. And then the N in this case would be associated with E. We would say that if we know the odds against, then the probability is m to n, then the probability of E is n over m plus n. Let's do an example. The odds against an event A are 9 to 7. What's the probability of A? What's the probability of not A? Because we have against right here, I know the first number I see, 9, is associated with A not happening. The second number I see, 7, is associated with A happening. So when I'm trying to find the probability of A, I want the number associated with A happening to come first. So I will put 7 in my numerator. My denominator will be the total of the two numbers, 7 plus 9. So the probability of A is 7 over 16. For the probability of not A, I want the 9 to come first. And then I'll have the same denominator, 7 plus 9. So I'll get the probability of not A is 9 over 16. I could have also used complements to get that. 1 minus 7 over 16 equals 9 over 16. Another concept you might see when you're talking about odds is expected value. The expected value is the sum of each x value times the probability of that x value for all possible outcomes x of an experiment. Expected values are used to predict the average results of an experiment when it is repeated many times, and expected values cannot be used to determine the outcome of any single experiment. We will use expected values in the unit to come to predict means for our distributions. What's a fair game? When payoffs are involved and the net winnings are 0, that means the expected value minus the cost to play the game of chance is 0. That means that we have a fair game. Let's do an example. Suppose you pay $5 to play the following game. 2 coins are tossed. You receive $10 if 2 heads occur, 5 if exactly 1 head occurs, and nothing if no heads appear. Is this a fair game? That is, are the net winnings 0? As you can see, I've taken the possible outcomes for the game and put them in a table with the amount you win for each. For 2 heads, $10. Head tail, $5. Tail head, $5. Tail tail, $0. Now each of these outcomes has the same likelihood of occurring. So the probability of each of those outcomes is going to be 1/4, because there are 4 outcomes that are equally occurring. Now, I'm going to say that let's call our winnings x, and we'll call each of these probabilities p of x. You might notice here that exactly 1 head appears twice, so we can condense this table. The probability of winning $10 is 1/4, the probability of winning $5 is 1/2, and the probability of winning 0 is 1/4. Now, we were asked to find the expected value, and to get the expected value, we take each x value and multiply it by its probability, and then we'll add them all up. So I'll take 10 times 1/4, and I'll get 2.50. 5 times 1/2 is 2.50, and 0 times 1/4 is 0. Now what I need to do is find the sum of x times p of x. What that is simply the sum of the numbers in this column. And when we add them up, we get 5. The expected value is $5. We are asked if we have a fair game. To find that, what you'll do is find your net winnings, your expected value minus your cost to play. Expected value is 5, and we paid $5 to play. So that gives us a net winnings of 0. So yes, this is a fair game. Now that you've learned about odds and computed an expected value to determine if you have a fair game or not, what I'd like you to do is finish the last examples on the page. 1, 2, and 3. You can check your answers with the posted answer sheet. If you're having trouble, you can tune in to a video where I go over just those 3 problems.